In this video we'll talk more about solving exponential equations, and in this video we'll be talking about how to solve exponential equations using logarithms. So if you haven't spent some time learning about logarithmic equations and change of base formula and those kind of rules for logarithms, I highly suggest you do that before watching this video. So let's go ahead and just look at an example that's somewhat simple in terms of these problems. So we have 2 to the x equals 25. Now the problem here is that 25 is not a power of 2, or at least not a nice one. So we could probably sit here and think, okay, 2 to the 4th is 16, 2 to the 5th is 32, so it's probably somewhere between 4 and 5. Great. So at least we have a ballpark of where it should be. But we don't know exactly what it's going to look like. So when you hit something like this, another thing we can do is we can rewrite it as a logarithmic equation. And remember our little example, 2 cubed equals 8 if and only if log base 2 of 3 is equal to, or log base 2 of 8 is equal to 3. Forgive me there. So I'm going to rewrite it. Log base 2 of 25 is equal to x. Now, what you can do is essentially use change of base formula here. So x is going to equal, I'm going to use natural log, even though you could use common log if you like. So it'll be natural log of 25 divided by the natural log of 2. If you use the common logarithm, you should get the same thing. And I'll get a decimal approximation for it. And if I go to my calculator and I do that, I will get 4.64385,619. And remember, that's only good to 8 digits for my calculator because that's all that it's got, or all that it can do. It's going to keep going, but this is a decimal approximation, and this is our exact expression for what it would be. And that would kind of make sense. It would land in our ballpark, somewhere between 4 and 5. That checks out. It's worth to kind of make sure, that way in case you happen to forget a parenthesis or something and you get something really wacky, you'll know. So there's our governing thought. The idea is we try to make it to where we have something to a power is equal to a number, then convert it into a logarithm, and then we'll probably use change of base formula somewhere in the mix. So let's take a look at another example that's a little more complicated. So if we're looking at this equation, I want to solve for x, and the first thing I think we ought to do is we ought to try to isolate this exponential term, this expression here. So the first thing I'm going to do is I'm going to add 7 to both sides. So 3 to the power of x plus 1, or no, forgive me there. I'll fix that up. 3 times 2 to the power of x minus 1 is equal to, looks like 20 if I add 7 to both sides. Real quick, I'll just get rid of this extra slash, alright. And then we can divide by 3. So 2 to the power of x minus 1 is equal to, let's just leave it as fractional form, 20/3. Now at this point we're in a very similar position that we were in with our last example, so we can convert into a logarithm. And again, you can write down that example I use all the time. It helps me keep things straight. So we're looking at log base 2 of 20 divided by 3 is equal to x minus 1. And just keep in mind that's your entire power. The minus 1 has to come over here. So then at this point, we can convert to, or use change of base formula. So we'll have natural log of 20 over 3 divided by the natural log of 2 plus 1, because the add 1, right, is equal to x. And at this point, I'm going to leave it right there, but we could run to our calculator, calculate our expression, and actually get a decimal approximation. But this is our process. This would be an exact expression. This is how we would find our solution. And this can be kind of your governing thought. Move it until you have a number to a power is equal to something, convert to a logarithm, and then use change of base formula. And this will work for solving any exponential equation where you have exponents on one side and numbers on the other.